Okay guys, so we are going to take a look at things that are called piecewise functions. Okay, section 2.7. Piecewise functions. Okay, I don't know, I think it's probably new. I think this is probably new for you, unless you maybe did it in 8th grade or something, just making sure that when I write this, it's in the window of the video. So, what will happen here is they're going to give you a couple of functions, okay? And they'll say something like this. F of x is equal to. And then they give you two different functions. This first one's going to be x plus 2. And the second one's going to be 2x plus 1. And then they give you conditions on when these functions are active. This one's x is less than 2, this is x is greater than or equal to 2. So when you look at these, it's a piecewise function. It's one function, okay, kind of split into two. So that when these are your x values, this is like your domain. When you're talking about numbers that are less than 2, we consider this function. When we're talking about numbers that are greater than or equal to 2, then we consider this function. In the first part, they just want us to find some values. So they want us to find f of 0, f of 2, and f of 4. Find f of 0, f of 2, and f of 4. So, f of 0. Normally, you just take your function and plug it in for x. However, here, you're going to see which one you're supposed to use. X is 0. Well, 0 is not greater than or equal to 2. 0 is less than 2, so I've got to use this function. So this function tells me to do 0 plus 2. 0 plus 2 is 2. So the answer to f of 0 is 2. F of 2. Well, 2 is not less than 2, so I can't use that one. 2 is greater than or equal to 2 because it's equal to 2, so I have to use this one. So I plug the 2 in here. 2 times 2 plus 1, 2 times 2 is 4, 4 plus 1 is 5. F of 4, well, again, 4 is greater than or equal to 2, so I've got to use this function. So it's going to be 2 times 4 plus 1. 2 times 4 is 8, and 8 plus 1 is 9. Okay? So if they ask you to evaluate functions like that, that's how you do it. Okay? That is how you do it. But more often than not, what they're going to have you do is they're going to have you graph these. Okay? So let's look at an example that they're going to have us graph. Actually, you can do that one. I'll put that one back up. F of x equals x plus 2 when x is less than 2, and 2x plus 1 when x is greater than or equal to 2. Okay? So, when we graph these, you're going to have, sometimes you're going to have things going in opposite directions, okay? And what you need to do is you need to create an XY chart for each of those situations. So I'm going to do this one first. This one's a little bit easier. It's a little bit easier for you to think of. So if they said x is greater than or equal to 2, that means x could be 2, it could be anything bigger than 2. So I'm going to put 2, I'm going to put 3, I'm going to put 4. And that's enough. Okay, that's enough. So let's plug that in. Plug a 2 in. 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. Plug a 3 in. 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. Plug a 4 in. 2 times 4 plus 1. 2 times 4 is 8. Plus 1 is 9. So I go to my graph. And I graph 2, 5. 1, 2, 1, 2, 3, 4, 5. And 3, 7. 3, 6, 7. 4, 9. 4. 8, 9. Now, can you agree it's going to continue to go on? Like if I put 5, then it would be 11. So this is an end point. and this goes on with an arrow, okay? So we've done our first part. Now we want to do our second part. We want to do the x plus 2 when x is less than 2. So we try to think about what we're going to put for our xy chart. X has to be less than 2. So some of you might say, okay, don't write this down yet. Some of you guys might say, okay, well, if x is less than 2, then I'm going to put 1. And someone might say, or I'm sorry, yeah, x is less than 2. Someone might put 1. Well, someone will say, well, what about 1.5? Okay, well, I'll put 1.5 right above it. And someone will say, well, what about 1.9? Well, yeah, you got 1.9. There's no smallest value there that's close to 2, because you could be using decimals, you could be using fractions. So what I suggest you do is I suggest you put this number in, right here. Well, we're going to plug in 2. And you're going to say, well, wait a minute. 2's not a solution to this piecewise function. And you're right, it's not. So what I do is I'm going to put a little loop over this. Okay? And the reason I put a loop over that is that's to remind me that when I graph it, I have to graph that coordinate, okay, that ordered pair with an open circle. So x is less than 2, now I can pick 1 and I can pick 0. Well, let's plug that in, let's see what we got. If I plug in a 2, 2 plus 2 is 4. Again, open circle. 1, 1 plus 2 is 3. 0, 0 plus 2 is 2. So I go to my graph. And I have to graph 2, 4. Over 2, 1, 2, up 4, 1, 2, 3, 4. Again, that's an open circle. Okay, it's not a solution. If it was a solution, it wouldn't be a function. Okay, so I put an open circle there. 1, 3, over 1, up 3, 1, 2, 3. And then 0, 2, 1, 2, and then I put a line. So there is my piecewise function. Why is it still a function? Because it passes the vertical line test. Okay, I could be making vertical lines here. Okay, and anywhere, ooh, I don't want that. I want this one. Anywhere I make a vertical line, it's only hitting my function in one spot. So that is how you graph a piecewise function. Come on. I don't know why the marker does that. So, let me give you one to try. F of x equals 3x plus 2 and x minus 1. 3x plus 2, x minus 1. In the top one, we're going to do that when x is less than or equal to 3. X is less than or equal to 3. X is greater. Okay? So I want you guys to try that. Okay, so let's take a look, see if we can get you guys started at least. If you're not done, just pause the video, okay? And when I tell you to do this, and I'm telling you for your own good, I think it's the way that you're going to benefit the most from this is if you actually try these before I'm doing them, and then when I do them, you can check yourself. If you're just sitting there and you're just either not taking the notes or just kind of listening to the video while TV's on and something else, well, then, you know, it's not going to be that helpful to you. Okay, I can't control what you're doing when you're not with me. Okay, so it is what it is. Let me do this one first. x is less than or equal to 3. So I'm going to pick 3, and then I'm going to pick numbers that are smaller than 3, 2, and 1. Plug a 3 in. 3 times 3 is 9, plus 2 is 11. Plug a 2 in. 3 times 2 is 6, plus 2 is 8. Plug a 1 in. 3 times 1 is 3, plus 2 is 5. So we go and graph it. 3, 11. 1, 2, 3. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. 3, 11. And then 2, 8. 2, 10, 9, 8. And then 1, 5. Over 1, up 5. 1, 2, 3, 4, 5. Now, I got to figure out which way it's continuing. Okay, I would say that if I put a 0, I'm going to get a 2. So it's going to continue to go down. So I don't want my arrow to go this way. I want my arrow to go this way. Okay? Now I've got to do the other one. So I make an XY chart for this. And I'm trying to think about where I'm going to start. I always start with this number, but I'm going to put an oval around here that reminds me that when I graph that, it's going to be an open circle. Okay? So greater than 3, I can put in a 3, I can put in a 4, I can put in a 5. So let's put in a 3. 3 minus 1 is 2. Put a 4. 4 minus 1 is 3. Put in a 5. 5 minus 1 is 4. So 3, 2, 4, 3, and 5, 4. 3, 2. 1, 2, 3 over 2. 1, 2. And that is an open circle. 4, 3. 1, 2, 3, 4. 1, 2, 3. And 5, 4. 5, 1, 2, 3, 4. Looks like this. Still a function. Still passes the vertical line test. So that is still a function. And that's how you graph a piecewise function. Okay? So I have one more I want to look at with you. Because I think it's interesting what happens in this one. I think it's interesting, and I want to show you at least one of these. So f of x equals, let's do 1/2 x plus 3/2. 1/2 x plus 3/2. And then, whoops, negative x plus 3. This is when x is greater than or equal to 1, so that means that has to be less than 1. They can't both be greater than or equal to or less than or equal to. Okay? So please pause the video, push pause. I want you to try to graph this one. We'll see if you guys can do it. I think you can. I have confidence. I have a lot of confidence in you guys. So pause that video, give it a shot. Okay, so I'm hoping that you paused the video. I'm hoping that you listened. Again, I don't have much control over that. Well, let's look here. I'm going to do this one first. X is greater than or equal to 1. 1, 2, 3. Plug those numbers in. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Negative 3 plus 3 is 0. I go to my graph. Figure it out first. Let's go back to blue. All right, 1, 2, over 1, up 2, closed circle. 2, 1, over 2, up 1. Over 3, up 0, 1, 2, 3. Okay, now again, it's gonna, if I put in a 4, it would be a negative 1 and so on, so I know that my line is gonna go this way. Okay? So now let's look at the other one. So I make my XY chart for the other one. Again, I'm going to put a 1 here. I'm going to put an oval there so I know that when I make it, it's going to be an open circle. So that's going to be 1/2 plus 3/2. Well, 1/2 plus 3/2 is 4/2, which is 2. Interesting. Put in something less than 1, put in a 0. 0 plus 3/2 is going to be 3/2. Put in a -1. -1 times 1/2 plus 3/2. -1/2 plus 3/2 is 2/2 or 1. So I go over here and I got to graph that. 1, 2, over 1 up. It's the same point. So I'd be putting an open circle around a point that's already shaded in, so interesting, isn't it? It's over 0, up 1.5. It's going to look like an absolute value graph almost. -1, up 1. So it almost looks like an absolute value graph, but it's not really symmetric because the slopes are different. Okay? So that is how you graph piecewise functions. Okay? Piecewise functions. So there's a special type of piecewise function that's called a step function. And I wanted to go over one of those with you. This is a great marker, by the way. You're like, wow. Some of these markers are lousy. This is a great one. It works great. You guys can hopefully see it. So here is what's called a step function. F of x equals 1, 2, 3, 4. This is when if x is greater than or equal to 0 but less than 1. This is when it's less than or equal to 1. I'm sorry, less than 2, greater than or equal to 1. And then this is going to be 2 and 3. And this is going to be 3 and 4. Okay? So, let's do that first one. So, first of all, if I had a graph that said f of x is equal to 1, or y equals 1, that's going to be a horizontal line. And the reason they call this a step function, you're going to see in a minute, is it's almost like we're going to create some steps. We're going to make all these horizontal lines. That's what we're going to do. So the function says that between 0 and 1, with a closed circle at 0 and an open circle at 1, okay, on the x-axis, you want a line y equals 1. So let's do that. Okay, let's do that. So again, it's going to be the line y equals 1. So I'm going to have a horizontal line somewhere here, somewhere where y equals 1. And I want a closed circle at 0. And I want an open circle at 1. And I'm going to make a horizontal line. Okay, there's my first step. Let's look at the next step. The line y equals 2. Here's the line y equals 2. Okay? That step is going to happen with a closed circle at 1 and an open circle at 2. So here's 1. Okay? Here's when x is 1. Here's when x is 2. Open circle and closed. And then you can kind of see the pattern. This one's going to be closed, this one's going to be open, and then this one's going to be closed, and this one's going to be open. And there's our step function. That is how you graph a step function. Okay? Take a look at that. I hope that makes sense. Okay? I guess I should have you guys try one. And that'll wrap up this section. That is going to wrap up the section. Isn't that a great thing, huh? Fantastic little thing. Here we go. So f of x equals 1, 2, 3, 4. X equals 1, I'm sorry, y equals 1, y equals 2, y equals 3, y equals 4. This is, and then they're all going to be f. And let's do x is greater than -4 to 3. -3. -3. Excuse me. -4 to 3. -3 to 2. negative 2